Okay, yesterday we finished the procedure for the level of service of signals. We discussed the 9 warrants which are required for the signal. Okay, very at the end when you are discussing this. So this is for railway crossing. So if you have a railway crossing near the intersection, then you can apply this one. Okay, so we have the distance which is from the stop line to the crossing. And usually crossing is on the minor street. Obviously, you cannot have the railway line crossing the major street, right? Okay. So crossing on the minor street. So if you want to see the warrant, then you come here, and you will see how much traffic you have on the minor street. Okay, crossing the minor street, which is. So traffic on the minor street here, traffic on the major street here. For the minor street, we will only use one direction flow. For the major street, you will use both directions of flow. So you plot these points and you will see how much is your distance. Okay, for example, this D is, let's say, 34 meters, let's say. Okay, so if your point is above this curve, that means the warrant is fulfilled. If your point is below this curve, then the warrant is not fulfilled. Okay, so each curve is for a different distance of the railway line from the intersection. Okay, and it is measured, you can see, from the stop line of the intersection to the edge of the railway line. Okay, this is the edge, right? This is the edge, so we are measuring till the edge. This is for one lane approach, and if you have 2 lane approach, you will use this curve. Okay. Okay. For the last warrant, again, we are still on the last warrant. The minor street volume should be multiplied by 3 adjustment factors. The minor street volume for the last warrant must be multiplied by 3 adjustment factors. The first adjustment factor for train volume. Okay, how much train volume do you have? How many trains are using the railway line? Presence of high occupancy buses. Okay, or buses, just buses. Okay, adjustment for buses and adjustment for trucks. Okay, and these adjustment factors will be applied only if you don't meet the base conditions. What are the base conditions? If you have 4 trains or less per day, this is base, no need for adjustment. If you don't have any buses, obviously you will not apply the adjustment for buses. If the trucks are less than 10%, no adjustment required. Okay, so these 3 adjustments will be done if you don't meet the base condition. If you don't meet the base condition, then you take the adjustment factors from here. Okay, the first one is for the trucks, this one is for the trucks, this one is for the trains, and this one is for the buses. Okay, 3 adjustment factors. So if there are no buses, you will not apply this. If the percentage of trucks is less than 10%, you will not apply this. Okay, if the number of trains passing per hour, the railway line, is less than 4, you will not apply this. Clear? Okay.
Trains per hour or per day?
Per hour per day. Per day. Sorry. Per day. Okay. The intersection data is given. Okay. So these are the volumes for the east-west direction, for the north-south direction. Okay. East-west, you can see which one is the main street. East-west is the main street, right? The bigger street. Okay, the bigger road. And this is the minor road. Okay. So you can see it already has stop signs. These are symbols for stop signs. The delay in the peak hour is given. Okay, 30 seconds per vehicle. It is for the minor street. Okay, we only need it for the minor street. Okay. The data is given from 11 a.m. to 11 p.m. How many hours? 12 hours. crashes data is given. You have 4 right angle crashes with injuries. 4 right angle. This is right angle. Okay. Left turning with injuries. So somebody taking a left turn, okay, and maybe hitting the vehicle which is coming from here or from the other side, from this side, whatever. Okay, so left turning. Rear end is this one. Okay, one behind the other. And pedestrian meaning the pedestrian was crossing and it was hit by the vehicle. So these are the crashes we have. For each one we have a number. Okay. Volume for each direction and the total for the main street. Okay. For north-south, volume of each direction and which one of them is higher. It's not the total, okay? This is not total. This is the higher one. Pedestrian volume, which is crossing the main street. The pedestrians are crossing in which direction? They are crossing the main street. Okay, so they are crossing like this. Okay, they are crossing this. So, yeah. So we have to see if the warrants are applicable here or not. Okay, the first warrant was for 8 hours. Okay, the first warrant is 8 hours. Now you see the main road has how many lanes each direction? 2. And the minor road has 1. Okay, I'll go to the two or more, 1. Okay. Minimum 8-hour volume 600 for the major total. Minimum minor 150 for one direction. 600, 150, 8 hours. Okay. Do I have 8 values here more than 600? More than 8, right? Do I have 8 values here more than 150? We don't. Okay. So the first condition did not meet, right? Look at the second condition. Again here, right? I'm here. 975. Do I have 8 values here more than 900? Yes. Yeah. Do I have 8 values here more than 75? You have? Yes. So condition 2, condition B satisfied. We are talking about warrant 1. Condition B is satisfied completely, right? So I don't have to look at anything else. 80% or 70%. Okay? Completely satisfied. Okay? Are you satisfied or not? You are not. Huh? Satisfied. Okay.
What about A?
One of them is enough. A or B, yeah. Why not? Clear? Okay. So according to this warrant, you can provide a signal. Condition B satisfied, signal is required. Clear? Okay. But just for the sake of wasting our time, we will do the other warrants as well. Okay, the next one is for 4-hour volume. Okay, so we need to plot the points. Okay, first of all, where are we? We are in the normal zone. Okay, they did not say it's a small town or high speed road. So we are here. So what we will do? We have how many hours of data? 12 hours of data. We will plot the points. Okay, minor road higher volume and major road total. Okay, we will plot them. Okay, which graph I am looking at? 2 or 2, 2 and 1, right? Looking at this one. Okay, the middle one. You plot the points. This is for how many hours? 4 hours. So out of the 12 points, if 4 are on the curve or above, this warrant is satisfied. Clear? Okay, they already did the plotting. You see all the points. How many points are above the curve? Only one. Okay, so this warrant is not satisfied. Okay, the next one is for peak hour. The next one is for peak hour. Again, you will do the same thing. You will plot the 12 points, okay, minor higher side and major both, okay, and you are looking at again this curve and how many points you need above the curve? Peak hour, only one, okay, but there's nothing here, okay. This one has two conditions. This is condition 1. This warrant has two conditions. This is condition 1, okay. The second condition was okay. If you meet all three conditions, then you can still provide a signal according to this warrant. Okay, what are these three conditions? Total stop delay experienced by traffic on the minor road, which is controlled by the stop sign, is equal to 4 vehicle hours for one lane approach. For a one lane approach, our minor road has one lane, right? Our minor road has one lane, so we are looking at this value. If it had 2 lanes, I would be looking at this value. Now they are saying the total should be 4 vehicle hours or more. Okay. Now this warrant is for the peak hour, right? It's for the peak hour. Okay. Which one is the peak hour? Tell me.
For the minor road.
Minor road.
140
140, right? Where is it?
from 4.
No, I'm saying something else. Ah, sorry. No, this one.
125.
125. Okay, and per vehicle is how much?
Yes.
36. So how much is this total? 30 into 125. How much?
62.
Huh? 62.5. 62.5 is what? Hours? Seconds? What did you do? 30 seconds into 125. And then you need it in hours.
3,700.
See?
That's it.
Same. Okay. Total delay 3,750. Okay. This is seconds, right? This is seconds. So how many in hours then? Almost 1 point something hours, right? So it's not 4 hours. 1 point something. 1 point how much? 1.04. Okay. So it's not 4 hours. Okay. So we did not meet the condition. Okay. What they are saying here, you have to meet all of them. You have to meet all of them. So if you did not meet this, this is done. We are out of it now. Okay. But just for the sake of wasting of time. Okay, the volume on the same minor street equals 100 vehicles per hour in one direction. Does it? Yes. It's 125, right? So exceeds 100. Okay. Total entering volume in the same hour is more than, no, we have 4 approaches. So more than 800 for the major. So this is also fulfilled. Okay. If you look at the peak hour, so we are talking about this hour, right? So minor should be more than 100, it is, and the major should be more than 800. So if the delay was not a problem, this would have been met. Okay, if you have got the delay 4 hours or more, this condition would have been met. But right now, not met. Okay, so we tried the first condition using the graph. We did not meet. We tried the second condition using the delay and the volume. We did not meet. Okay. So warrant 3 did not meet. Warrant 4 is about what? 4 hour pedestrian volume. Okay. So we will use the first graph. Now we will plot the pedestrians which are crossing the major street, the ones which are given. They only give it for one street, the one which is required, and major street total. Okay, so we plot How many points? 12. We'll plot 12 points. And how many should be above the curve? 4. Okay, I believe they did this. Good. Yeah. So this is for 4-hour pedestrian volume. This one is for peak hour, I think. Yes. Okay, so 4-hour, you can see there are 6 points actually above the curve. Okay, so this warrant is met, fulfilled. Okay, so again we can have a signal according to this warrant as well. So warrant 1 met, we can have a signal. Warrant 4 met, we can have a signal. Warrant 5 was peak hour pedestrian volume. We have a different graph, but again you do the same thing. You plot 12 points. Now you need how many points? Only 1, but all of them are below the curve. So this warrant not met. And then we have other warrants as well. For example, warrant for pedestrian crossing. Warrant for school crossing. Okay, it's not near a school, or even if it is, it's not given. We cannot use it. A warrant for signal progression. Signal progression means you already have signals which are around it. Okay, and this is the only unsignalized intersection. Okay, so it will make it better if you signalize it as well. But the information is not given about the other intersections. I cannot do it. Okay. Warrant 7 is about the crashes. Okay. Crash data is given. I can apply it. What does it say? Yeah. You have to meet all these conditions. You have to meet all these conditions. The first condition is adequate trial of alternatives have been done previously. Okay. So you can see they already put the stop signs. Okay. We will consider that they did it. Okay. 5 or more crashes which can be corrected by a traffic signal in 12-month period. Okay. Each involving an injury or property damage. Okay. Property damage, injury means somebody got injured. Property damage is nobody got injured, but the car was damaged or the property was damaged. Okay. So we have 5 or more in the 12-month period. Tell me, do we have?
Yes.
Okay. We have total 4 plus 3 plus 5 plus 3. Okay, total is how many? 7 plus 5, 12 plus 3, 15. Total 15. Okay. Are all of these, or can all of these be corrected by a signal? All 15 crashes, can it be corrected by a signal? We are only looking at crashes which can be corrected by a signal. You put a signal, these crashes will become low. Which of them? At least some of them, right? Which of them?
Right angle maybe.
Right angle, obviously. Signal will block one of the travels, right? Okay, what else? Left turn, obviously. And pedestrians. What about this one? No. Okay, this is rear end in the same direction. It has nothing to do with the signal. If you don't like the guy in front of you, signal has nothing to do with it, right? You go and crash with it. Clear? In fact, on signals they become more. Okay, because of the yellow, you can see there's yellow, and yellow means your eyes become green, right? So that's why. So yes, this one, the number of crashes they meet. What else? Okay, what's the third condition? We are saying what? All of the following are met. Okay. So what's the third condition? For each of any 8 hours a day vehicles per hour given in both 80% of the column point A or in both 80% of the column in B. Okay, so the third condition is that you meet the 80% criteria for warrant 1. What was the 80% criteria? Now, do I need to check it?
No.
Because I met what? 100%. So why should I check? Okay. Okay. So other measures are tried. Number of crashes met, and this one also met. So according to this, we can have a signal there. Warrant 8, again, you need more data about the road geometry, the surrounding road network. We are not given with this. And warrant 9 is about a railway crossing. There is no railway crossing. Okay, so you can see some of the warrants are not applicable. Okay, so we have signals according to warrant 1. Okay, warrant 4, which was pedestrian, 4-hour volume, and we have crashes. Okay, they wrote something, yes. Okay, so according to these, the signal should be used. Okay, it is obviously you have now 12 crashes, which you are hoping that they can be reduced by the signal. So crash experience supposed to become better. Okay, the fact that warrant 1B is satisfied. Now warrant 1A, the 8-hour volume. I'm talking about the 8-hour volume. If you meet warrant 1A, that means both directions according to their capacity have high volume. Both minor road and major road, according to their capacity, they have high volume. That is A. B says that the major road volume is so high that if you keep it unsignalized, the minor road will not get a chance to enter. So that also means what? That the major road has very, very high volume and the minor road compared to that has very, very low volume. Okay, so that's why they are saying that maybe you should apply a signal which is semi-actuated. Put a sensor on the minor street. Okay, sensor will do what? Because the minor volume is very, very low compared to the major, so the sensor will only open the minor road when it is required, because both of them are not high. This one is very high and this one is very low. Okay, so our sensor will make sure that the signal does not become red unnecessarily. Clear? So this is their recommendation. Warrant 4 means the pedestrian, use the pedestrian at least for pedestrian crossing the major street. Yeah. You are using a semi-actuated signal, so maybe there is no car on the minor road, but there are pedestrians waiting. Okay, so maybe it can be provided with a push button as well. Okay, so maybe there is no car for 15 minutes on the minor road. But what about these pedestrians? You met the pedestrian warrant, right? Okay, so number of pedestrians is high. Okay, so you can provide it with a push button so they don't wait unnecessarily. Clear? Okay, so now this tells you what? According to which warrant you have satisfied, you can decide whether you want it semi-actuated, fully actuated, pre-timed, with a pedestrian button, without pedestrian button. Okay, clear? Okay, so it's not like, okay, we've fulfilled warrant 1 or 2, just go ahead with the signal. What type of signal can also be decided. Clear? Okay, we are continuing with the topic of signal timing still. Okay, so up till now we have discussed the procedure for calculating the level of service, and we have discussed what are the conditions in which you would provide a signal. And before that we discussed about the stop signs, the give way signs, in which conditions you will use them, and we discussed one criteria, which was what? We did some calculations for it as well. Criteria for which other thing we discussed for the intersection?
The side distance.
Side distance. Okay, so this we discussed in normal conditions as well as with the stop sign. Okay, traffic signals, these are the most analyzed form of traffic or the intersection control. Okay, because you are monitoring or you are controlling every aspect. On a stop sign, you just put the sign, right? You can control what? Side distance maybe. Okay, the road condition, that's it. You cannot control the behavior of the driver. You cannot tell him when to move and not to move. Okay, he decides according to his or her own judgment. Okay, and signals we control everything, when he should slow down, okay, when he should start moving and so on, okay, at least we think. So that's why they are the most analyzed form, because you are trying to control many aspects. It may not be the most common one, especially in residential neighborhoods, residential areas. They are not very common. Okay, and by the way, smaller roads, minor roads are more in any network. Minor roads are more as compared to major roads. Okay, so obviously signals are usually on the major roads. Okay, so they are not very common. Okay, but they are very important on the corridors which have congestion issues. Okay, so they are not common, but they are on important locations. Got it? They are not common, they are not everywhere, but wherever they are very important. Okay, they are on, as I said, major roads. Okay, and these roads have high volume, they have congestion issues. Clear? Okay, what are the components of a traffic signal? The components can be divided into two categories. We have the hardware and the software. We have the signal control cabinet. Okay, you may have seen it, right? On the side of the road with the policeman stands and so on. Then we have the sensors and detectors. Okay, sensors and detectors can be above the road, below the road, side of the road. Okay, and then we have the software part, which is within the cabinet. Okay, so there is a controller within the cabinet, and then we have the interaction platform with the traffic management center. If signals are controlled centrally, so there is a central control room where they can control the signals. There must be some communication between the center and the signal as well. They have a control center, but I'm not sure if they are controlling the signal or just monitoring it. Okay, I'm not sure, but they have traffic control center here in Bahrain as well. Okay, so we have the signal controller in the hardware in the cabinet. We have the signal controller, and signal controller has the logic, the program which is running the signal. Okay, so signal controller is that part of the signal which is actually running the signal timing. The entire sequence of signal timing is run by signal controller. Okay, then we have the malfunction management unit. Okay, this is like a safety button. Okay, like you have the breaker for the electricity, right? Whenever there's power is very high, very low, it trips. Okay, it drops. The same thing here. Okay, so if there is a problem with the signal, okay, it's not working properly, some of the lights are not working properly, or somebody messed up with the signal timing, something happened, okay, a short circuit or something. So this malfunction unit will activate, okay, and it will proceed the signal in a safe manner. Okay, so maybe, for example, there's a problem with one of the lights, it doesn't work. Okay, so the malfunction, so you will not see that light. Okay, so what will happen, you see, okay, green, and that's it. Okay, and you don't see anything else, the red light is not working, that's it. Okay, so the malfunction unit should then take over, and it will do what? It will block the regular function of the signal. Okay, it may switch off all the direction, or it may start flashing. Okay, so the drivers know the signal is not working. Okay, when they're coming to the intersection, they know the signal is not working, we have to go by our own decision. Okay, so to remove any problem, it can be because of a logical error as well, some error in the programming. So everything is working fine, the lights and the wiring and everything is fine, but there's a problem with the logic. Two directions are having the right at the same time. Okay, so shouldn't happen. Okay, so again in this case, this will start working. Okay, then we have a detector rack. Okay, so it's like a shelf, a rack, which has detector cards. Okay, chips which are installed in that, and so these are the ones which are connected with the sensors on the road. So this is the one which is collecting the sensor data from the road, and these cards, they then tell the signal what to do according to the information which is received from the sensors. So if you have 4 sensors or 5 sensors, each one will have a detector card. Okay, it will receive the information and then process it and then tell the signal what to do. Okay, then we have the field terminal, which is the interface between internal and external wiring at the controller. Okay, so we have the wiring going towards the signal and we have the wiring which is inside the controller. So the connection between them is called the field terminal. Okay, then we have the field transfer relays, load switches and flashers. They work in sequence. Okay, so these components, they help the software signals to be translated into the action of the hardware. Okay, even the laptops, even our phones, they have this. Okay, when you do something physically, okay, then the software will tell the mobile what to do. The software will tell the laptop what to do. Okay, so this is done by relays, switches and flashers. Okay, so relays transmit a pulse signal to the hardware device. So whenever you do something, okay, a signal is transferred to the device. Okay, load switches control the change of signal indications. Okay, so it will transmit the signal to the device. Then the load switch will change the timing, the light of the signal. Okay, and the flashers control the on-off sequence. Okay, so they are not used all the time. When you want to switch off the signal or something like this, then they will be used. And then we have the police switches. We know that, right? The only thing which we know about signals. Okay, clear? So they can manually control the sequence of the signals. Okay, so they are not controlling the lights. Actually, they are controlling the sequence. It's not like, okay, red here, green here. They are not doing this. Okay, they have their switchboard from where they initiate, okay, this direction next. A signal will perform its sequence to give the next green to that direction. Okay, so what is the sequence? If this direction is green and the policeman wants this direction to be green, what's the sequence? This one will turn into what? Huh? See, because of that, I'm saying that there's a sequence. Okay, so it will, from green it will turn to yellow, and then from yellow it will go to red. Okay, and there's a timing for yellow as well. Okay, so maybe he is saying, okay, this direction has too long queue, let me cut the yellow. He cannot do this. Okay, and again for that direction I want to do it fast. No, from red, what happens at the start of red? All red. He cannot cut off any time. Okay, he is just changing the sequence. Okay, so yellow, all red, then the next one will become yellow in our case, and then green. Clear? Okay, so he's manually controlling the sequence. He's just pushing the sequence ahead. Okay, so what do we have? We have sensors, okay, which are taking the information from the cars. Okay, and then we have the detector rack, which is taking that information and giving it to the controller. The controller decides the signal timing on the basis of that, which light will go on and so on and so forth. Okay, according to that, the cars move on the intersection according to lights, right? Okay, the ones which have green or yellow, they will move, the others will stop. Okay, so the lights tell who is supposed to go from the intersection, and from that movement it will go back again to the sensors. Okay, when the cars move, then it will go back to the sensors again. Okay, if you want to design signal timing, you have to follow these steps. Okay, so there are 12 steps. First of all, you have to identify the treatment for the left turning. Should the left turning be with the straight, or should the left turning have its own phase, and so on. Identify the lane groups. Okay, so all lanes in a lane group have what? If there are 2 lanes in one lane group, both of them have same movement which is in the same direction. Okay, so identify how many lane groups you have, how many lanes with exactly same movement. Okay, then for each lane group, find out the demand, find out the saturation flow rate, and then take the ratio of demand to saturation flow rate. Okay, for each lane group. So every direction may have 2 or 3 lane groups, and so on and so forth. Okay, so you have to do it for each lane group. Develop the phasing plan for the intersection. Okay, and phasing plan is developed on the basis of V by S ratio. We try to minimize the summation of V by S ratio. How do we do this? You will see it in the examples. But develop the phasing according to V by S ratio. Calculate yellow and all red time. There is a minimum value for them which can be calculated. Okay. Then we have to find out lost time for every phase and the lost time for every cycle. Okay. Lost time for every phase and lost time for the whole cycle. Okay. Lost time means what? Lost time means what? 12 to 12:50 UTMS, right? You didn't get it. Okay. What is lost time? Yes.
Lost time على طرق عشان تنقطها.
Explain.
There is effective green and there is.
There is effective green. There is all red.
When there are no vehicles in the intersection.
There are no vehicles in that intersection.
No.
No.
The time when,
The green with nobody moving.
Green will nobody move.
when no vehicle.
Who are
enters
these
the
people?
intersection. No vehicle.
When no vehicles are entering the intersection. Okay. They are not entering. Okay, because of preparation or because of all red, whatever. Okay. So this is the lost time. Phase. What is the phase? You cannot move forward, obviously. What is the phase?
Green face, yellow face.
No.
red face.
Wrong. No. These are intervals. What is the phase? This phase, huh? Don't say this. That is the phase.
From green to orange.
Green to all red, yeah. Good. Okay. From green to all red. Every direction has this. So phase. And then we have the whole cycle, which is summation of the phase. Okay. Select a target volume capacity ratio. You have to select as the design value. Okay. Now what is the difference between this and this? Volume capacity, volume to saturation flow rate. What's the difference between them? Both of them are considered as maximum flow rates.
Saturation flow rate does not include the stopping time.
Which one?
Saturation flow rate.
Saturation flow rate does not include the stopping time, lost time, anything. Okay. Capacity does. Okay. So this is the actual one. Then using these values, find out the cycle length. Okay. Then find out total effective green for the whole cycle. Then divide the effective green into the phases. Then from the effective green and the lost time, find out actual green. Okay. And then check the signal for pedestrian timings. Okay, or the pedestrian time requirements. Okay. So the last step is only required if pedestrian crossing is allowed. Okay. So we'll go step by step. We have the first step, identify the left turning movements category. There are 3 types. Left turning can be treated in 3 ways. You can treat them as permissive, protected, or a combined mode. Okay, combined, protected and permissive. Permissive means that the left turning doesn't have a separate phase. Okay, and it will go on if there is a chance. Okay, so they have a chance for left turning, they can take. There is no signal timing for them. This is permissive. Protected means they are following the signal timing. When it becomes green for them, they will do it. Okay, if it is red for them, even if the other road doesn't have any vehicles, they will stop. Okay, this is protected. And combination means some hours of the day they are permissive, some hours of the day it is protected. Okay, so the combination is a very unique case, and there is no equation, there is no check for it. Okay, you have to see and do the simulation and see if it will work or not. Anyways, for protected and permissive, we have some values. Okay, we have some values. So, for example, if you do left turn, multiply by the opposing. Okay, so if I'm taking the left turn from the east direction, from the eastbound direction, my opposing is from the westbound direction. Okay, So left into the opposing. The product, if the product is more than 50,000 with one opposing lane, the left turning should be protected. Okay, whenever you exceed these values, the left turning becomes protected. Okay, so the product more than 50,000 for one lane, 90,000 for two lanes, and so on. If you exceed these values, the left turning becomes protected. Okay, and what are these values? Left turning into the opposing, multiply. Okay. Other reasons for making the left turning protected can be these. Side distance, the left turning vehicles do not have enough side distance, so they have to be made protected. Okay, otherwise there will be crashes. The vehicles which are coming from the opposing direction, their speed is more than 45 miles per hour. So it's high speed road, so you cannot take a chance. You have to make the left turning protected. Presence of more than one left turning lane. Okay, so there are two lanes for left turning. Okay, then it's too risky to make it permissive. This driver may not decide, but the other one decides, or both of them decide at the same time. Okay, so more than one left turning lane, the left turning should be protected. Or you tried permissive and you saw there were crashes. Okay, so even in the last chapter I told you we have two warrants, two conditions which are common. Anybody remembers which ones? Crashes. Sorry, I pointed the other one. The crashes and the side distance. Whenever you have crash experience, obviously there is a safety issue. Okay, and the side distance. Okay, so whenever you have these problems, you will always go for the protected one. Okay. Yeah, they are saying don't go for the third option if there are safety issues. Okay, so don't go for it if there are already crashes experienced there. Okay, lane groups, we discussed this. Okay. So they are saying now for each lane group, find out volume to saturation flow rate ratio. Okay. Yeah. Then develop the phasing plan to minimize the summation of volume to saturation flow rate ratio. Okay. Volume to saturation flow rate ratio should be what? More than 1, less than 1? Less than 1, right? But we are calculating it for each what? Each lane group, right? Okay. So for one lane group it could be 0.1. For another lane group it could be 0.2. Okay. So you may have like 10 lane groups. All of them need the signal timing, right? Okay. So then we will do what? We will calculate their summation. And this summation should be in this range. More than this is dangerous. Dangerous in the sense of traffic flow. You may see very long queues or very long delays. Okay. Less than this, that means something is wrong. You are providing signal where maybe it's not required. The volume is too low then. Got it? So this range is considered appropriate. Okay. Yeah, what they are saying, yeah. When you are developing the phasing plan, we will see it. When you are developing the phasing plan, try to keep the lane groups which have similar V by S ratio in the same phase. Okay. So you may have, for example, you see this one. This is a lane group. This is a lane group, right? Okay. And you decide I will, this one has V by S ratio of, let's say, 0.1. This one has around 0.1. Okay. So the time required by this one and this one are also same. So if they are in the same phase, there is no wastage of time. Okay. Otherwise, what can happen? This one needs 0.2. This one has a ratio of 0.2. This one has a ratio of 0.1. Now, when you will design according to what? If they are in the same phase, you will design according to what? 0.2 or 0.1? 0.2. What about this one? It is having extra time for no reason. Okay. If I can combine this with another lane group which has around 0.2, so I will have low wastage of time. I can give another phase which is a small phase for this one according to its V by S ratio. Okay. So this is what they are saying. Okay. When you will draw the phasing plan, there are some notations which they follow just for the sake of uniformity. Okay, so nobody gets confused. So, for example, the pedestrian movements. The pedestrian movement are shown with the P letter. Okay, so if I see 6P, that means it's a pedestrian movement. If I just see 6, it means it's a vehicle movement. Alright? Similarly, right turnings. For right turnings, they use 10 plus numbers. Okay, so you see this is only 6 and this one is 16. Okay, so they add 10 into this one, the straight one, and they come up with a number for the right turn. So if you see a 10 plus number for a movement, that means it is right turn. Okay, then what else? Yeah, even numbers for through and odd numbers for left. Okay, so pedestrian movement with a P, letter P. Okay, odd numbers for left turn, even numbers for through, straight, and for right turning, what? Plus 10. Okay, and all of them are with respect to the through. Okay, so so this is 8 plus 10, 18, something like this. Okay, this is 8P. Why? Because this one is also 8. This is in the same direction, right? So this one 8 and this one 8P. So 8P is the volume of pedestrian in that direction and 8 is the volume of vehicles in the same direction. Clear? Okay, so some of the conventions which they follow, and just for the sake of uniformity. Okay. Yeah, then we need to calculate the yellow and all red time. Okay, so yellow is also called as change interval and all red is also called as clearance interval. Okay, why they are given? To make sure that the drivers who are already too close to the intersection, they clear. They don't try to stop because of sudden change in the signal timing. Okay, so they are given basically for drivers who are in the dilemma zone. What is the dilemma zone? This one is called the dilemma zone. Okay, drivers who are too far, a signal becomes red or yellow for them. They are already so far, they don't dare to stop. Okay, drivers who are too close, they are so close that they will not even try to stop. Okay, all of us, right? And then there are those drivers, okay, who are not here, who can think about stopping. Okay, somewhere in the middle. They are not too far, not too close. So this one is called as a dilemma zone. Okay, so yellow and all red time is basically for these drivers. Some of them will try to go, some of them will stop. Okay, so yellow and all red, their total should be enough for this driver who is in this zone to reach the other side. Okay, and they are this is a video as well. Okay, yeah, what does it include? The perception reaction distance plus the braking distance. Okay, this includes the perception reaction distance plus the braking distance. Okay, so from here, this point onwards, how much perception reaction and braking distance he needs, according to that you can calculate the yellow time. It's already part of the equation. This is the equation. Okay, so total, it is called as the change interval, y plus yellow plus all red. The total is called as the change interval. So the equation is here. Okay, so this one is yellow, this plus this is yellow, and this one is all red. Okay, if you go back to the equation of side distance, perception reaction and braking distance, side distance, you will see this is the same equation. Divide by s, divide by speed. Why? Because I am calculating what? Yellow what? Time. Okay, so distance upon speed, time. Okay, and this is according to what? This is distance upon speed. Which distance is this? W is the width of the intersection, stop line to the other side. L is the length of the vehicle. Okay, so all red is calculated for a vehicle to cross the entire intersection and reach the other side, like completely. nothing behind the other side. Okay, so this one is the distance the driver needs to stop at the stop line, and this one the time the driver needs from the stop line to reach the other side completely safely. Okay, so this is the yellow and this is the all red. Clear? Okay, as you can see, this is fixed according to the dimension or the speed or the design of the road. Clear? Okay, any questions? So we'll discuss the rest of the steps tomorrow.